Dear students, today we shall take up some examples involving tracing of curves in Cartesian coordinates. The steps involved in tracing of curves in Cartesian coordinates have already been given to you in the previous lecture. So kindly revise those steps. Let's take the first example. Trace the curve y into x square plus 4a square is equal to 8a cubed. Now if you look in the equation of the curve, you see that we have got here x square. That means powers of x are even and nowhere else you will find x. So curve is symmetric about y-axis. Now 0, 0 does not satisfy this equation, because if you put x and y equal to 0, you will see 4a square is this will be 0, and on this side you will have 8a cubed. So it doesn't satisfy. So the curve does not pass through the origin. To find points of intersection with axis, if you put x is equal to 0, then we get y is equal to 2a. And if you put y is equal to 0, 8a cubed is 0, so you don't get any value of x. So therefore curve crosses the y-axis at 0, 2a. Now we shift the origin at 0, 2a, and then equation of the curve becomes, how do we get this? We replace y by y plus 2a and x by same x plus 0. So we have y plus 2a into x square plus 4a square is equal to 8a cubed, and if you simplify it, we will get x square y plus 4a square y plus 2a x square is equal to 0. Now in this equation, degree of this term is 3, degree of this term is 1, and degree of this term is 2. So lowest degree term is this one. So lowest degree term is y is equal to 0. That means tangent at the point 0, 2a is y is equal to 0, which is new x-axis. That means a line parallel to original x-axis. To find asymptotes parallel to x-axis, what is the highest power of x? We got here x square. The coefficient of x square is y. So therefore asymptotes parallel to x-axis is given by y is equal to 0, that is x-axis. And the last step is to find out regions where the curve does not exist. So from equation of the curve you find out x square is equal to 8a cubed upon y minus 4a square. Now from here you see that if y is negative, then x square is negative, and if y is greater than 2a, then also x square is negative. So therefore curve does not exist for y less than 0 and y greater than 2a. That means curve lies between y is equal to 0 and y is equal to 2a. So taking all these points into account, we draw the equation of the curve like this. Curve is like this. This is the asymptote, x-axis is the asymptote. Curve passes through 0, 2a. Tangent at 0, 2a is new x-axis, means a line parallel to x-axis. Right? Okay. Let's take next example. Trace the curve xy square is equal to 4a square into 2a minus x. Now in this case we got y square, so curve is symmetric about x-axis. 0, 0 does not satisfy this equation, so therefore curve does not pass through the origin. To find out points of intersection with axis, we put y is equal to 0, and if y is 0, then from here we get 2a minus x 0, that means x is equal to 2a. So therefore 2a, 0 is the point on the x-axis. Now shift the origin at 2a, 0. So replace x by x plus 2a, y by y plus 0. So this equation becomes x plus 2a into y square is equal to 4a square into 2a minus x plus 2a. So if you simplify and equate lowest degree term equal to 0, we will get x is equal to 0. So x is equal to 0 means new y-axis, means a line parallel to y-axis. Asymptote parallel to y-axis. The highest power of y is 2, so coefficient of y square is x. So that means asymptote parallel to y-axis is x is equal to 0. X is equal to 0 means y-axis. And last step, regions where the curve does not exist. Now from here you see that if x is negative or x is greater than 2a, then y square is negative. That means curve does not exist for x less than 0 and x greater than 2a. So taking all these points into account, shape of the curve is like this. Curve passes through 2a comma 0. At 2a comma 0, tangent is new y-axis, a line parallel to y-axis. Y-axis is the asymptote. So we draw the curve like this. Third example. Trace the curve ay square is equal to x square into a minus x. Now because we have got y square here, so curve is symmetric about x-axis. 0, 0 satisfies this equation. So tangents at the origin are obtained by equating lowest degree terms equal to 0. So we have got y square is equal to x square. That means y is equal to plus minus x. And because tangents are distinct, therefore origin is a node. For finding out points of intersection with the axis, we put x is equal to 0, and if x is 0, then we have got y is equal to 0, and if we put y is equal to 0, we have x is equal to 0 or x is equal to a. So therefore 0, 0 and a 0 are the points of intersection with the axis. As far as 0, 0 is concerned, we have already seen that origin is a node. And for finding out tangents at a comma 0, we shift the origin at a0. So we replace x by x plus a. So equation becomes ay square is equal to x plus a whole square into a minus x plus a. Simplify it and equate lowest degree term equal to 0. Lowest degree term will be obtained from here, a square into this. So lowest degree term is x is equal to 0, means new y-axis. There is no asymptote because coefficient of highest power of x as well as coefficient of highest power of y, both of them are constants, so there are no asymptotes. Regions where the curve does not exist, because equation of the curve is a by square is equal to x square into a minus x. So you can see that if x is greater than a, then y square is negative. That means curve does not exist for when x is greater than a. So now draw the curve like this. See, this is the point a0. At this point we have got tangent as new y-axis. At the origin we have node, tangents are y is equal to x and y is equal to minus x, and curve exists for negative values of x. So we draw the curve like this because curve is symmetric, so it's like this. This point is a node because tangents are distinct. Fourth example, trace the curve ay square is equal to x cube into 2a minus x. A square y square is equal to x cube into 2a minus x. Because we have got y square, so curve is symmetric about x-axis. Since 0, 0 satisfies this equation, so therefore curve passes to the origin and tangents at the origin are obtained by equating lowest degree term equal to 0. And lowest degree term is y square is equal to 0. That means y is equal to 0 comma 0. And because tangents are identical, therefore origin is a cusp. So the point where tangents are identical is known as cusp. Points of intersection with the axis. Now if you put y is equal to 0, we get x is equal to 0, x is equal to 2a. Now 0, 0 is a cusp, and for finding out tangent at 2a comma 0, we shift the origin at 2a comma 0. Then equation becomes a square y square is equal to x plus 2a whole square into 2a minus x plus 2a. Now if we equate lowest degree term, again we get x is equal to 0. X is equal to 0 means new y-axis. So at 2a comma 0, tangent is new y-axis, a line parallel to y-axis. There is no asymptote parallel to either x-axis or y-axis. Regions where the curve does not exist. From equation of the curve you see that if x is negative or x is greater than 2a, then y square is negative. So therefore curve does not exist for x less than 0 and x greater than 2a. So draw the curve. See, 0, 0 is the cusp, so tangents are identical. 2a 0, we got this tangent, right? So the shape of the curve is like this. Okay, let's take one last example. Trace the curve x cube plus y cube is equal to 3axy. This curve is also known as folium of Descartes. Now in this case, if we interchange x and y, equation of the curve will be y cube plus x cube is equal to 3ayx, which is the same as this equation. So therefore curve is symmetric about the line y is equal to x. You can see 0, 0 satisfies this equation, right? So therefore curve passes to the origin, and tangents at the origin are obtained by equating lowest degree term, which is x into y is equal to 0. That means x is equal to 0 and y is equal to 0. So tangents are x is equal to 0 means y axis, y is equal to 0 means x axis. So these are the tangents at the origin. Now because curve is symmetric with the line y is equal to x, so we solve y is equal to x and give an equation of the curve. So we get these 2 points 0, 0 and 3a by 2, 3a by 2. 0, 0 is this point and 3a by 2, 3a by 2 is this point. Both of them lie on the line y is equal to x as well as on the curve. Now to find out slope of the tangent at this point, so what we do, we differentiate 3x square plus 3y square divided by dx is equal to 3a into x divided by dx plus y. So from here we get dy by dx is equal to ay minus x square into y upon y square minus ax. So at 3a by 2 comma 3a by 2 we'll obtain dy by dx is equal to minus 1. So dy by dx is equal to minus 1. That means tangent will make angle of 135 degrees with the x-axis. Now asymptote of this curve, there is a separate chapter for finding out asymptote. I'm not going to discuss that right now, but when you study a chapter on asymptotes, then you will learn how to find out oblique asymptotes. There is a method, several methods are there. Okay, so right now you just take it as x plus y plus a is equal to 0. This is the asymptote for this curve. And now you draw this curve. 0, 0 tangents are x axis, y axis. 3a by 2, 3 by tangent makes angle 135 degrees. This is the asymptote, so you draw this curve. Okay, let's take one last example. Trace the curve a square y square is equal to x square into a square minus x square. Now you see here that all the powers x, y, all are even. So that means curve is symmetric about both axes. 0, 0 satisfies this equation. So tangents at the origin are given by y square is equal to x square. That means y is equal to plus minus x. So therefore origin is a node. To find out points of intersection with the axis, if you put x is equal to 0, we get y is equal to 0. If you put y is equal to 0, we get x is equal to 0 and plus minus a. So therefore points of intersection with the axis are 0, 0, a0 and minus a0. Minus a0. We have already studied nature of the origin, which is a node. For finding out tangents at a0, we shift the origin at a0. And equation of the curve becomes a square y square is equal to x plus a whole square into a square minus x plus a whole square. Now you simplify it and equate lowest degree term equal to 0. Now lowest degree term will be x is equal to 0, that is new y axis. And last point, regions where the curve does not exist. From here you can see that if x is greater than a or x is less than minus a, then in that case y square is negative. So therefore curve does not exist for x greater than a and x less than minus a. And there is no asymptote which is parallel to x axis or y axis. So now you can draw, these are the tangents, y is equal to x minus x. This is the point a0 where tangent is mu y axis. So you draw here like this. And because curve is symmetric about both axes, so shape of the curve will be like this. There will be two loops. Okay. So I have discussed only those examples which I will be needing when I shall do the chapters on areas of curves, rectification and volumes. Okay. Thank you.